Hello everybody and welcome to a lesson for chemistry, which I think for some people is a tougher subject, or at least not hard to get the concept, but remembering it and so forth. And I think it's good to go over it, make sure everybody knows that they're covering the right thing. I know this isn't physics per se, but I'm currently just going to cover GCSE topics like combined science, maybe touch on some triple science stuff if I have to. But yeah, so today we're doing dynamic equilibrium and Le Chatelier's principle, which is paper 2, chemistry. So yeah, okay, so let's begin with reversible reactions. You need to know everything about your reversible reactions. So first of all, a reversible reaction is a chemical reaction where the reactions can form products that afterwards react together to give back the reactant. So you have, so you have A plus B, you add them together and you get C and D, or just C, something like that, and that C plus D can then turn back into A plus B. So it can just go back and forth basically. So so you need to know what equilibrium is as well. Equilibrium is when these two go back and forth until the rate of reaction on both sides are equal. So that means they will produce, in a closed system where nothing is changing, they will have the same number of molecules. So a way to show this is that A plus B, C plus D. Say you start with A plus B, which would be maybe, let's say it's an exothermic reaction. So one rule you need to know there is that if a reaction is exothermic one way, it must be endothermic the other way. So we add so you need it gives off energy when this is produced. So we produce this, we get C plus D, and we have energy. Let's say it's, 100 joules. Probably not realistic, but still. So that 100 joules, in a closed system, when nothing else is affecting it, no conditions have been changed or whatever, that 100 joules will be used to go back into A plus B, to react back into A plus B, or break down. And because it's endothermic, it uses up that 100 joules. So this will go back and forth until they have the same rate of reaction. And this is a graph for equilibrium. So as you can see, they start at opposite ends, and over time they come to the point where they have the same rate of reaction. So it starts higher for the forward reaction, because that's the first reaction that we start, and we don't have any reaction here because you can't have both at the same time. So this begins to decrease and this begins to increase, and they join together basically to reach equilibrium where both rates of reactions are the same. So next is Le Chatelier's principle. Now this is higher tier only, so you don't need to know this per se. So with Le Chatelier's principle, it involves being able to predict what will happen if you change the conditions inside a closed system of a reversible reaction. So like I said before, a closed system is where nothing else from the outside is changed. So to put it better, closed system is where, say you have a reaction going in here, bubbles, 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 but it's in a box, and you take out anything else that is not involved in the reaction, and that's a closed system where the outside cannot affect this reaction. Now, we control this reaction, so if we change the conditions, we can predict what will happen with Le Chatelier's principle. So let's begin with temperature. So if you increase the temperature, this means that there will be extra energy. So you've already got your, let's say we're doing, this is the, what's it, the reversible reaction we have happening. We have nitrogen, some hydrogen, and that turns into ammonia, I think. Yeah, we get ammonia. So because we're at this point, we're going this way, because we're forming one molecule of that, so we're forming a bond between these two. This will give us an exothermic reaction because we're producing energy by making a bond. So, like I said before, imagine, okay, so we have 100 joules here, and when you increase the temperature, that increases the overall amount of energy in the reaction. So let's say when we increase the temperature, we get another 100 joules extra. So here, there will be more endothermic products reacting. So we will form more reactants because it's the backwards reaction is endothermic. We need to use up more of that energy to equalize the rates of reaction, and that's dynamic equilibrium, where the rate of reaction will stay the same because the equilibrium will shift to keep it that way. So, because we've increased it like that, there will be more reactants formed, so more products are breaking down to form reactants. Now, if you decrease the temperature, let's say that turns into, I don't know, 50 joules. So we've got half the amount of energy that we did before. The reaction will shift to produce more products because we need to form more energy. Well, not form, but transfer more energy to the surroundings. So these, rather than it going backwards and producing more reactants, we go forwards in the reaction and produce more products. Now, let's move on to concentration. So, concentration usually involves, your liquids and your gases. Let's say here it's probably going to be gases because it's nitrogen and hydrogen. So, when you increase the number of if you increase the concentration in the reactants, so if you increase the concentration in the reactants, the outcome is it means there will be more products formed until the equilibrium shifts to fix it again so that the rate of reaction is the same. Now, if you decrease the reactants, there will be more reactants formed by going through the backwards reaction because of the dynamic equilibrium. Okay, so now let's talk about concentration. So, concentration, when you increase the concentration in the reactants, it will increase the amount of products formed. So you probably wouldn't increase both of them at the same time, but just one of the reactants. So say we add more nitrogen. So more products will be formed until equilibrium is reached again, till the rate of reactions are the same. Now, if you decrease the concentration in one of these reactants, or increase the concentration of the molecules of the product, the equilibrium will shift so that more reactants are formed. So that's for concentration and temperature. Temperature, if you increase the temperature, more reactants will be formed because it will have to go through the endothermic backwards reaction, although it's not always endothermic in the backwards reaction. Or if you decrease the temperature, it will have to go through the exothermic Ford's reaction to produce more products. And with concentration, if you increase the concentration in one of the reactants, it will produce more products until equilibrium is reached again. And if you decrease one of the reactants in terms of concentration, the more reactants will be formed by going through the backwards reaction to reach until you reach equilibrium again. Now, let's talk about pressure. Pressure is not really talked about that much in combined science. It's more of a thing that you cover in triple. But pressure is just, say this is a gas, okay, in a box. Well, not in a box, but in a ball. Now, let's say we just keep the same amount of gas in there, like 1 gram of gas in there. Now, if you put the same amount in a smaller area, the same mass in this gas, the pressure will be higher because there is like a smaller area, like the same amount of gas is contained in a smaller space, so they're going to hit the walls more, and that will cause like more force on the ball. So if you increase the pressure of a reversible reaction, if you increase the pressure in the reactants, more products will be formed until equilibrium is reached. So if you increase, say, nitrogen, there will be more ammonia. Now, if you decrease the pressure in the reactants, so if you, let's decrease, so forget about this one, that it goes back to normal, and then if you decrease the amount of hydrogen there is, it will produce more reactants until we reach equilibrium again. Okay, shut up, Domingo. You are actually retarded. Okay, so with pressure, if you increase the pressure of the entire thing, so basically with the reactants, equilibrium will shift to side with the side of smaller numbers of molecules. So that would be, we would increase the number of products, because here we have 1, 2, 1 and 3, so 1 molecule of nitrogen and 3 molecules of hydrogen, so that overall gives us 4 molecules on this side. Now when you put that all together and you go through the reaction to this side, you only get 2 molecules, as shown here. So that means that we'll get more products. However, if you decrease the pressure, if you decrease, equilibrium will shift to the side with the most amount of molecules. So this side, there will be more reactants formed. So it's always like increase, something happens, decrease, the opposite things happen. So you're better off just remembering one part of what happens for each one. So with temperature, let's go with, if you increase, there will be more reactants. So all you need to know is that for the decrease of temperature, it's the opposite. So there will be more there will be more products formed if it's a decrease. So basically just imagine it as like, I don't know, never mind. And then with concentration, if you increase it in one of the reactants, you will get more products. And remember, this is all until it reaches equilibrium again. The reaction will always shift to reach equilibrium. That's what dynamic equilibrium is. Because dynamic means that it's always changing. It will always change to make sure that the equilibrium is reached. And then with pressure, simple as you increase, you'll get more of the side with smaller molecules, or less molecules, sorry. So like I said, here you've got, on this side of the reaction, you've got 1 nitrogen molecule and 3 hydrogen molecules, so you've got 4 molecules overall on this side, and here you've only got 2 molecules because of the 2. So when you increase the pressure, you'll get more ammonia molecules, and if you decrease the pressure, like I said, the opposite of this, you'll get more reactants, you'll get more nitrogen and hydrogen. So basically, these are the only things that you need to know, and you will be asked to, in tests and whatever, to interpret the data they'll give you. So maybe they'll give you an equation like this, and they'll ask you to predict what happens if you, say, increase the pressure or decrease the temperature. They'll ask you what happens and what happens to the products or what happens to the reactants, and you need to know these things. So I hope you've enjoyed today's video. Please like and subscribe for future videos. I will be covering GCSE subjects, well, only the sciences, obviously. If you want any videos that I should cover that people want, then leave a comment down below. Tell me what you want me to cover. And thanks for watching the video. I'll see you in the next one.